In this video, we're going to look at fractional exponents and how the properties of exponents can be used to simplify expressions with fractional exponents. Alright, let's look at these two problems, and these are going to be done differently. So we're going to compare and contrast these two. So the first one, we have the square root of 6 times the square root of 2. And we've done problems like this before. We know that we can factor 6 as 3 times 2. So this is just the same thing as saying the square root of 3 times the square root of 2 times the square root of 2. And we know that by definition, what's the square root of 2 times the square root of 2? Well, that's just 2. So our final answer here would just be 2 times the square root of 3. Alright, now if we look at number 2, this problem is different. We cannot do the same thing that we did on number 1, right? Because this is a square root and then this is a cube root. Right, so we can't treat this problem the same way. Alright, but what could we do? Well, one thing we can do is we can rewrite this problem using fractional exponents. So the square root of 7 is the same thing as 7 to the 1/2 power. And the cube root of 7 is the same thing as 7 to the 1/3 power. Right, and how does that help us? Well, I want you to notice that I have two expressions here with exponents, and they have the same base. Right? Well, let's recall our properties of exponents. Right? We've learned previously what happens when we have x squared times, let's say, x to the 4th. Well, here I have 2 factors of x. Here I have 4 factors of x. Right? And that multiplies to become x to the 6th. Right? There's 6 factors of x. Right? Or you can think of it as these exponents add. 2 plus 4 is 6. Right? So that same idea is going to happen here. So 7 to the 1/2 times 7 to the 1/3 is the same thing as 7 to the 1/2 plus 1/3 power. Right? So our exponents can be added. And to simplify that, let's just add those fractions. Right? Let's do this over to the side. 1/2 plus 1/3. Right? Well, to do this, we need a common denominator. Common denominator is going to be 6. And let's see, to change 1/2 to have a denominator of 6, let's see, I can multiply the denominator by 3. So multiply the top by 3. So that's 3/6. And then on the second fraction, I can multiply this by 2 and multiply the top by 2. So this is 2/6. So 3/6 plus 2/6, that's the same thing as 5/6. So our answer here would be 7 to the 5/6 power. Okay? And if you like, you could change that back to having radicals. Right? What does 7 to the 5/6 power mean? Well, there's different ways you could write that. Right? We could recall that we could write this as 7 to the 1/6 power raised to the 5th power. Right? And that's true by the property where if I have an expression with an exponent raised, that whole expression raised to another exponent, that these can be multiplied. Right? 1/6 times 5 is the same thing as 5/6. Right? So if we wanted to write this as a radical, what does this mean? This is the 6th root of 7 raised to the 5th power. Right? Or, if we like, we could do it this way. We could write it as 7 to the 5th raised to the 1/6. And again, by the property of exponents, this 5 times 1/6, we can multiply those. That's 5/6. Right? And what does that mean if we write that with a radical? This is the saying 7 to the 5th power, and then we're taking the 6th root of all that. Right, so really, there are 3 different ways to write your answer. You have 7 to the 5/6, which is the same thing as the 6th root of 7 to the 5th power, or that's the same thing as the 6th root of 7 to the 5th power. Right, so all 3 of these things are the same. Alright, so let's look at 2 more. Let's look at some division. Right, we have the square root of 15 divided by the square root of 3. Alright, so on this one, let's see, I could factor the square root of 15 as the square root of 5 times the square root of 3, and I'm dividing that by the square root of 3. Right? Well, in this one, let's see what happens. Well, radical 3 divided by radical 3, that's 1 over 1. So this just becomes the square root of 5. Okay, well that was easy. Now, if we look at the second one, unfortunately this one isn't as easy. Right? And why is that? Well, it's because on the top here, this is a square root, and on the bottom, this is a cube root. Right? So I can't do the same type of factoring and simplifying that we did on number 3. Right? So what am I going to do? I'm going to rewrite these using fractional exponents. So this is the same thing as saying 5 to the 1/2 power divided by 5 to the 1/3 power. Right? And how does that help me? Well, let's recall our properties of exponents. Right? If I had x to the 6th power divided by x squared, right? Well, what does that mean? That's 6 factors of x on the top divided by 2 factors of x on the bottom, right? And 2 factors on top and bottom are going to divide out, leaving me with x to the 4th power, right? And you can think of that as the property is saying 6 minus 2 gets me 4, right? So we can apply that idea here, right? So 5 to the 1/2 divided by 5 to the 1/3, right? That's the same thing as saying 5 to the 1/2 minus 1/3, right? And so we'd have to subtract those exponents, right? So 1/2 minus 1/3. 1/2 we already said is the same thing as 3/6, and 1/3 is the same thing as 2/6. So 3/6 minus 2/6, this is just 5 to the 1/6 power, right? Or we could write that as the 6th root of 5. So both these are the same. Alright, I want you to do these two. Right? So first I want you to change these so that they have fractional exponents, and then simplify them. Alright, go ahead and pause and do that, please. Let's see if you got it right. So the first one, we can rewrite this as x to the 1/5 power times x to the 2/3 power. Right? And we can add those exponents. Right? So this is the same thing as saying x to the 1/5 plus 2/3 power. Right? Let's do the fraction work maybe over here to the side. Right? 1/5 plus 2/3. We can use a common denominator of 15. The first fraction I'm going to multiply by 3 over 3. So that's 3/15. The second one I'm going to multiply by 5 over 5. So that's 10/15. So my final answer should be x to the 13/15. Alright, the second one. X to the 4th divided by the cube root of x. Right, well, this is the same thing as saying x to the 4th divided by x to the 1/3. Okay, and this is the same thing as saying x to the 4 minus 1/3. Right, so let's subtract those exponents. So let's do the subtraction over here. 4 minus 1/3. Well, that's the same thing as 4 over 1 minus 1/3. And to get a common denominator, let's stick with 3. So the second one doesn't need to change. For the first one, I can multiply this by 3 over 3. Oops. So that's the same thing as 12/3. So 12/3 minus 1/3 is 11/3. So this answer is x to the 11/3. Okay, and if you like, you can, remember, with these answers, rewrite these in different ways. Right? So if you like, think about the different ways you could write this. Right? I'm not going to show the work right here, but just so you know, right, this could be rewritten as the cube root of x raised to the 11th power, or you could rewrite this as x to the 11th, or the cube root of x to the 11th. Right? Those are the other ways to write this answer. And if you like, for the first one, if you are interested, right, you can pause and, if you like, try to write this out in the different ways. But this is the 15th root of x raised to the 13th, or you can think of it as x to the 13th power, the 15th root of all that. Right? That's just kind of a side note. All right, last one, last page here. So let's think about how the properties of exponents could help us here. Well, for 7, let's think about this. This is saying the 6th root of x cubed, right? Or we can think of this as x cubed raised to the 1/6 power, right? And with the properties of exponents, we know that these exponents can be multiplied. So this is the same thing as x to the 3 times 1/6 is 3/6, right? So, and 3/6, well, with that we know that fraction, that could be reduced to be x to the 1/2. So the 6th root of x cubed is actually the same thing as the square root of x. Okay, either one of those answers is fine. Alright, last one. We have the cube root of 125 x to the 6th y to the 12th. Right? Well, remember, the cube root is just the same thing as taking all of this to the 1/3 power. So we have 125 x to the 6th y to the 12th. And then the whole thing is going to be taken to the 1/3 power. Right? And we can think of this as taking the individual pieces to the 1/3 power. Right? So it's 125 to the 1/3 times x to the 6th to the 1/3 times y to the 12th to the 1/3. Alright, go ahead and pause and see if you can come up with the final answer. Alright, here's the final answer. 125 to the 1/3, or the cube root of 125, we should know that. That's 5. Alright, this one, x to the 6th to the 1/3 power. Right? Well, we could multiply these. 6 times a third is 2. So this is just x squared. And then the last one, y to the 12th raised to the 1/3, that's just y to the 4th, because 12 times 1/3 is 4. Right? So the final answer is just this, 5x squared y to the 4th. Okay? And just one side note, does that make, let's think about it, does that make sense? Does that make sense that the cube root of 125 x to the 6th y to the 12th is the same thing as 5x squared y to the 4th? Right? Well, it does. Right? Because remember what a cube root is. Cube root is saying I need to find the thing that if I multiply this, if I have 3 factors of this, I would get back to here. Right? And that's exactly what we have. Right? If I were to take 5x squared y to the 4th and cube that, right, what would I get? Right? I would get 5 cubed is 125, x squared cubed, that's x to the 6th, and y to the 4th cubed, that's y to the 12th. Okay? So that's kind of further intuition about why this answer makes sense.